just present. I'll bring you live.
Oh,
So, uh, good evening, everyone. It's again, you are welcome to the AWS Study Series. And today we have our presenter, Prosper Agada, a cloud engineer, an AWS builder, and he'll be presenting to us uh, s- building a workflow system using AWS Cloud Step Function, using AWS Step Function. And today, uh, let us know where you are listening from. We'd like to hear from you, your location, where you are joining from. And it's a pleasure to have you on our study series. This week, make it the 10th since we began the CS study series. We've had wonderful presentation. We've had different engineers, DevOps, security experts present topics on building scalable, reliable solution on AWS. And this week again, it's filled with nuggets which Prosper Agada will be sharing insight how to build scalable using step functions on AWS to build. And so let us know where you are listening from, where you are joining from, and it's a pleasure to have you today on AWS Cloud Series Study Series. Scalable using step functions on AWS to build. And so let us know where you are listening from, where you are joining from, and it's a pleasure to have you today on AWS Cloud Series Study Series. Also, if you are joining, know that there are prizes to be won. Those prizes, will go a long way in enabling you in learning, developing on AWS. We have a cloud session at the end of the session presentation by Prosper, and you do well to listen, and so you could win a prize, and this prize will go a long way. So, any from wherever you are listening, let us know your location. So, not to bore us and waste your time, not to bore and waste your time, I would just like to read uh, the bio of our presenter and our speaker today, the person of Prosper Agada, and then after which I'll invite him to the stage and have take it up from there. And so Prosper Agada is a DevOps engineer, a technical pre-sales architect, and a technical instructor with a passion for empowering others through cloud technology. So today we have a DevOps engineer, a cloud, someone who has understanding with extensive experience building manageable cloud native application on AWS, Azure, Google Cloud, and is specializing on DevOps, containerization, Kubernetes, as infrastructure as code, and cloud system architecture. As an educator and mentor, Prosper has trained inspiring cloud and DevOps engineers. So you have someone who has both the practical and training aspect. So today we have someone who has in depth. So we it would do well for you to listen and gain insight from someone with such in depth of experience. And so Prosper is committed to continuous learning, community engagement, inspiring the next generation of cloud professionals through workshop, technical session like this, and collaborative learning. So today we'll present to you our speaker, Prosper Agada, as he takes it from there and present his topic to the community today. Thank you so much. Do well to listen. And if you have questions, you can drop it on the chat and we will surely you know be answered by Prosper. Thank you. So, Prosper, you have the floor. You can put your on a slide mode so that people could actually.
Okay. So thank you very much, Mr. Kunle. Thank you very much. I really appreciate the introduction. All right. So I'm so glad. I'm so excited to be here this evening. And yes, we have a lot to talk about. But with the little time allocated to me, I'll try as much as I can to cover much grounds. All right, so let's dive straight to what we have for this evening. So this evening we're going to be talking about building workflow systems using AWS Step Function and Lambda, and I'm going to walk you through the theological part of things, how what workflows actually means, how things were done before now, and where step function comes into the picture. So we are going to look at that, and at the end of this session, we are also going to do a little um, um, to test out this particular topic. All right, so first we'll discuss about the problem. So what problem do Lambda what problems are we trying to solve? Okay, so how are things done initially, and how we are going to be using AWS step function to solve this problem. Okay, so we cover also concept on step functions, the different type of workload we can run on step functions, and some key tasks that step functions is good at. So we are going to look at that. Also, we are going to do a live coding where we are going to see how we can deploy a simple payment processing application on AWS step function. Okay, so after the whole session, I'm going to send across my resources to those that need access to that. So I'll be dropping my GitHub link to this project as well, so you can follow through when you're at home, okay, or when you are trying to build this yourself. All right, so let's dive into the problem. Okay, so how many of you have actually ordered something from an e-commerce website before? Okay, how many of you have tried ordering, let's say, a bag or a gadget from Temu? I think most of you would have tried that. So a typical workflow would look like this. So you go on Temu, you pick a wireless headset, you pick a laptop stand, and you hit order. Okay, so this is a typical workflow for a day user. So this is what you do. But at the back end, what really happens at the back end? So at the back end, we have multiple services that spins up to actually make this process to run successfully. Okay. And I think most of us here, or some of us here, have actually heard about microservices before. Okay. So if you've heard about microservice before, this wouldn't be a new thing for you. So microservices is actually a kind of an architecture where services are being decoupled from each other. Okay, so we have multiple services running independently, and they are all working in a system to make uh, a process or a transaction successful. Okay, so in this setup, we have six microservice application running at the back end for this order for this Temu application. Okay, we are using Temu as a case study here. So after the customer click on place order, so the first thing is that the the first service, which is the validation service, or the order validation service, runs a validation check to see if the order is valid, after which it moves to the charge card service. So this service charges the card. Okay, so this is where you input your PIN. So if the service has an integration with Flutterwave or with Paystack, that is where you see your banking options, and you put in your pins and all of those stuff. So after that, it now moves to the reserve inventory. So this is where your order will be placed on the reserve. Okay, so inventory will be updated, and your profile as well will be there will be a reserve that is being there will be a reserve that is being kept. Your order will be kept for you at the reserve. Then from there, we have the shipment service, which is the courier service that will be triggered to actually set up the shipping of your service. Then you get an email, and you also get updates to analytics. So this is just like a basic um, setup, okay, for an e-commerce application. Then let's see, everything looks very fine. So as a developer, you are tasked to set this up. This actually looks very clean, okay. But let's dive deeper into where the problem and the bottleneck starts. All right, so the first instinct of a developer, so a developer that is working and is using Lambda for deployment. So what is Lambda? So most of you might ask, or some of you might be new. And yes, so Lambda is actually an event-driven service. So it's used for running event-driven applications. So applications that highly depend on some certain events and some certain triggers can be run on Lambda. So it's more of like a compute service for running some workload that needs trigger basically. Okay, so that's what Lambda is doing. You you deploy a developer deploys his application, his microservice application on Lambda, for instance, for this use case. Okay, so you place an order, and the order hits Lambda. Okay, and this is the first service on the Lambda service, which is the validation service. So this service will run validation to see if your order is actually available. If it's not available, then it throws back an error, or it gives you something else. Okay, so that's just like validation, validating if that order is actually um, can actually be carried out. Okay, so if um, if you if it is being placed, then it heads to DynamoDB. Okay, so it heads to DynamoDB. DynamoDB there is used for logging. Okay, so it logs the order in. Okay, it logs the transaction, so the date, the time when the transaction was placed, the order that was made. Okay, so everything will be kept in DynamoDB, and it will also invoke another Lambda function. Okay, so I call this chaining lambdas together. So you have a lambda function, and in that lambda function, you chain another lambda function. Okay, you chain another lambda function to perform a task. Okay, so that's what is basically happening here. So you have the validation order service triggering the card charge service. So the card charge service, this is where the card is being charged. Okay, so the particular uh, amount that have been that has been that was placed on the item will be checked out from the card. Okay, in that during that process. Okay, so we also have another Lambda service still um, chained to this service, okay, which is the reserve stock service. So inside of our first Lambda service, we chained another Lambda, okay, to get reserve stock. And also, we also chained another Lambda service, which is for the shipment. Then you now have your emails and notification service. So this is typically how a, a regular deployment will look like. Okay, typical deployment for a transactional application. This is how it will look like typically. Okay, nothing too special. Everything looks clean. Okay, and it's a bit easy, I would say, for the developer trying to deploy using this model of deployment. So we call it the chain model. So you chain a particular Lambda function to another Lambda function, okay, based on some certain parameters. So if this function is to get triggered, then do this. Okay, so you just use Python. All these things are written using Python. Okay, so you've scripted out, you've written your Python, in your Python code, you define your functions, okay, the validation order function, the charge card function, or any kind of SDKs you are using. Okay, so all of this will be scripted on on the the Python script, okay, that you'll be deploying. So, so everything goes quite fine, okay, but this architecture is not scalable, okay, and we are going to be looking at how this is not scalable. We are going to be looking at the bottlenecks to this, okay, to this kind of architecture. So, one of the first thing you would notice is that the first the first order. So let's assume after a month of deploying this application, a user places an order and the order gets validated, meaning the order is available. The user gets logged to the DynamoDB, okay, and card gets charged, okay. So the user card gets subcharged, and something happens, the user doesn't get an email or the user doesn't see anything about the order getting tracked. Okay, so that sparks a problem. So you you begin to wonder, okay, as a developer, where is this problem coming from? Where is this challenge coming from? Okay, so this could be due to, let's say, Lambda timed out. Maybe the order was taking too long to process and Lambda timed out. Okay, or Lambda was, or let's say the server was out of memory. Okay, that's OOM, out of memory. Then, or you have an exception error. So there is an error that there's an exception error, meaning that the error neither failed nor was successful. Okay, and all of these processes were chained together, meaning if anything is to happen to one process, it affects the remaining process. Okay, so they are in the bracket of the coupled architecture, right? But they are still very dependent on each other. Okay, so when a particular service goes down, it still affects the rest of the service beneath that service. Okay, so that's what is happening here. So when card gets charged and reserve stock get gets an issue or gets an error, it affects the email service, affects the shipment service, and you as a developer, you begin to think, where is the problem? Where is the problem coming from? Then you try to debug things, right? So first, you try to check your CloudWatch log to see where the issue is coming from. Okay, so you check the 5 services from your watch log to see where the bottleneck is coming from. And to your surprise, you can't actually pinpoint any definite um, error code from that log. Okay, so how are you going to retry? Okay, so in some cases, that in this kind of case, okay, how will you retry the logic? Okay, so uh, if a request gets dropped, how are you going to retry the request? So you begin to think about that. So you begin to add some complexity to your code. Okay, so you begin to say, okay, what am I going to do? So you add a retry logic to your Lambda function. Okay, then how are you going to compensate the people that their card get deducted? Okay, how are you going to compensate them because they didn't get a refund, okay, immediately? So how are you going to consolidate your account and give them their compensation, okay, or refund back their money? How are you going to do that? So That's another challenge you face in this kind of setup. Okay. Then how do you audit this setup? Just like I said, you're having multiple services and they're all generating logs and pinpointing the exact error. Sometimes might be challenging. Okay, so these are some of the challenges, okay, faced when chaining Lambda services together or running Lambda service traditionally. Okay, then Lambda is not a problem actually. Okay, Lambda is not a problem. It is the architecture you are using for the deployment that is the problem. So, what is Lambda doing versus what Lambda cannot do? So, let's look at that. So, you have it in mind, or your philosophy, you thought Lambda could handle both logic and also orchestration, okay, which partially that's not the case. Lambda performs better when running logics, okay, running logics for your application. That is where Lambda excel, that's compute. Okay, so compared to orchestration, meaning tasking other um, sub services or tasking other dependent services on what to do, Lambda does not excel in those side. Okay, so Lambda prefer executing a single task or some couple of tasks on compute that will best suit what you want to do at that point. Then so you also try to Lambda also is you also try sometimes you also try to do managing retry logics inside of Lambda. Okay, so you write a function inside of the Lambda code to do the retry logic. Okay, which is not the best. It will make your code cumbersome. Okay, and everything will spiral to become a spaghetti code at the end. Okay, so it's always better to leave those things outside of Lambda. Okay, it's always better to abstract all those stuff outside Lambda. So tracking of states, Lambda is not good at tracking state. Lambda is not good at handling error compensation, that's handling refund and all of those things. Lambda is not good at knowing when to do that. Okay. Also knowing about downstreams. So Lambda is not good at that as well. So we need something that is more like a manager, okay, in this sense. Something that is a coordinator, something that can coordinate Lambda on what to do. So Lambda is the muscle, right? We need a brain that can orchestrate orchestrate this uh, this application for us. Okay, so that is where step function comes in. Okay, so step function is basically an orchestrator. It's basically an orchestrator that helps to orchestrate our workflow. Okay, so let's make another analogy, right? So you are you are driving you are driving to VI, and you are driving to VI, and you jump on Google Map, right? You jump on Google Map, and let me use Uber for instance. So you book an Uber, and you are to go to a location at VI, and you don't know the location. This is your first time actually going to that place. You don't know the location, so you jump on Google Map to direct you on where to go. Okay, the direction, the navigation, okay, of the route to that particular location. So Google Map is not driving the car, right? What Google Map is doing is to direct the driver on what to do, the right turn to make. Okay, so that is what Google Map is doing. So that is also what you can you can say step function is doing here. So step function is not running the code. Okay, it's not running the code, it's not running the logic. What step function is doing is that step function is serving as an orchestrator. So it abstracts the layer of complexity that you need to put inside of your code. That layer that you need to logically write in your code, it just abstracts that layer and makes it easy for you to chain resources together. Okay, not only Lambda, you can chain multiple resources DynamoDB, S3, um, relational database, and all any kind of all those services on AWS. You can actually chain them easily, okay, using Lambda. So that is what a workflow is. So a workflow is actually like a pattern, okay, of which a particular problem is being solved. So it's a pattern you use in solving a problem. So first, the user comes, places an order, what happened next. Okay. After that, what happens next? After that, what happens next? So it's like a chain of order. So that's actually workflow. So step function helps you to orchestrate that workflow. All right. So step function describes your workflow as a state machine. Okay, so in step function, there's something called the state machine. So the state machine is it helps you to define what you want to execute. Okay, the services that you're going to be chaining together, the services that you're going to be putting together, you're going to be orchestrated, will all be defined by the state machine. And then you visualize. It's also helps you to visualize what you're actually doing. So every execution step by step in the AWS console is being visualized. So it also gives you like a visual view, like a graphical view, to see what's actually happening. Okay, in your workflow. So it gives you that graphical interactive UI where you can easily drag and drop, and you can easily make things happen, make design your workflow using step function. It's also very resilient. So it has built-in retries, catching error, timeout, zero infrastructure as code is required. So it has built-in retries and error, catching error. So you don't need to actually um, write in code to do that any longer. Automatically, step function can do the retry for you. So you are building an application, and instead of you writing a function separately for retry, step function can catch the error and do the retry for you, or even set a wait, okay, it like a delay as well to delay for a request if a request drops. So that's a very good feature in step function. Then let's see the difference between lambda and step function. Okay, so this is the most important concept tonight, right? So the lambda is is solely working as the worker, okay, whereas the step function is job is to conduct. Okay, so the lambda runs your code. Okay, the lambda runs your code. The code you write your code in. After writing your code, you deploy it to Lambda, and Lambda runs the code simply. So one task at a time. It runs it one task at a time. It is stateless, meaning it is not persisting any state. So once it runs the code, it just goes to rest. And Lambda knows nothing about what is going to happen next. So you relieve Lambda of of knowing what to do next. Okay, so Lambda just runs the code and goes to bed. Okay, so the validation order, the card charges, and the create shipment. So they are all run independently of each other. So they don't know what's actually going on. Okay, so they are all running independently, and they are not, let me say, too dependent on each other. Okay, meaning if validation order is to fail, it doesn't affect the whole system, or it doesn't start from afresh. Okay, because if a card gets dropped, okay, if a request gets dropped, okay, you have to go over the whole um, you have to go over the whole process from afresh. Okay, so it's removes that complexity. So if an issue happens at the card validation section, it stays there until that issue gets solved. Okay. All right. So the step function, what the step function is doing is deciding what to run next. So since Lambda is running your code, step function will be doing the scheduling. So it will decide on what will be deployed next, or what tasks will be scheduled next, and on what service will that with the task be scheduled on. Okay. Then it also track your overall state as well. So it tracks what's happening from the top down to the last state. So it tracks everything, and it also holds your business flow as well. So it's very intuitive. So it gives you this graphical UI that you can easily understand your business logic. Okay, so instead of just coding, you have like a graphical interface to understand what's going on in the system. Okay, so you know the entire sequence, you know what is being ordered, you know what is being retried, you know the errors that that you know the errors, okay, encountered. So that's um, the major difference between the lambda and the step function. Okay, so a workflow is just like a state machine. Okay, a workflow is just like a state machine. So don't let the term intimidate you, state machine, right? So just like I said, the workflow is actually the state machine. So this is where you define what and what you want to execute. Okay, so you define your start, your order, your preparing, your ready, and your pickup. So this is a typical workflow, right? So this is a typical workflow for Starbucks. Okay, Starbucks coffee company. So this is a typical workflow. So you place an order, the order goes to preparing, it goes to ready, and it gets shipped to you. Okay, so this is how a typical workflow for Starbucks will look like. So this can be regarded as your state machine in step function. Okay, so any moment the order is a so every every event is being led by a previous trigger, right? So if there is a trigger from start, then order placed will commence. After order place is done, it triggers another event. For it invokes the lambda for preparing to prepare, and that's how the workflow goes. Okay, step by step. Then every state has a purpose. Okay, so in step functions, we have some key things in step functions, some key purposes, some key functionalities in step function you can actually use. Okay, so we have the tags. So the tags calls the lambda, the APIs, AWS services directly. Okay, so what tags does is just to make the calls. So step function with the use of IAM. Okay, your IAM roles, it integrates with other AWS services, and it can connect with them, okay, easily. Also the choice, we also have the choice. So it branches based on the data. Okay, so no code, just condition on your JSON field. So the step function has many logics. Okay, so you have the if logic, for instance, where the choice is more like an if logic, if else logic. So if this is to happen, then do this. Is that okay? So you don't need to type in the code in your Lambda to do that any longer. So it has the branching logic for you. So it can take a particular part if some certain criteria are met, or else do the other stuff. Then we also have parallel. So if you have multiple services you want to run in parallel, so you can use the parallel function in step function. So you run multiple branches simultaneously, wait for all to finish. Okay, so it runs multiple branches and wait for them to finish. So you can run multiple programs in step functions. Then we have the wait function. So it pauses for time, or it pauses for a time, and or it waits until a particular callback is made, or arrives. Okay, so like the wait, you can set a wait in your step function. Let's say you want a man in the middle, where you want like validation of human validation for a particular processing. So you can put a wait that actually pauses your workflow until the approval, the human intervention or the human approval is being made to trigger the continue. Okay, so that is also possible with step function. So you are building some application that will require a manual trigger, then you use step function for that. We also have the map. So the map is basically used for iteration. So if you're having multiple functions to run, okay, so you can have them instead of having a dictionary and or having a list of items or a list of functions and iterating through them, how you would do with your Python. You can use the map function here in step function. So the map function iterates through the whole table and runs them one after the other. Then we have the success and fail. So if it fails, what will happen? What should happen? If it should succeed, what should happen? So you can easily define all of these things using your step function. Okay. All right. So how are workflows defined? So how do we define our workflow, or how do we set up our workflow on step function? So your workflow are defined using JSON. That's the Amazon State Language, ASL. So the ASL helps you to define your your workflow in step function. So we have the validate order. You script all of this stuff. So if you are comfortable coding and you actually maybe you want to use infrastructure as a code to deploy your application. Let's say you want to use Terraform, Terraform, or you want to use Pulumi or any IAC tool at all of your choice. You can define what you want using this Amazon State language. So you define what you want, the workflows, and you can easily integrate those code with your Terraform, okay, for state management. And you can also manage this the same way you manage your resources. Okay, so you have a Git workflow that you check out this code to your Git, and automatically it triggers AWS and it pulls, it takes up from there to set up these functions for you. That's same thing you do with your Terraform basically. So it can also work. You can also do the definition using this on AWS. So two workflow types. So we have two workflow types. We have the standard workflow and we have the express workflow. So they are basically similar, just few differences. Like the standard workflow, maximum duration it can last up to 1 year. Okay, whereas the express workflow can only last for 5 minutes. So depending on the kind of workload you are trying to run. So if it's a workload that is going to last for a year, then you go with your standard. If it's something that is just going to run short term, then you go with your express. Also the model of execution as well. So workflow can run exactly once, okay, whereas express can run at least once. Then the audit history as well, you get um, full history per execution, full history per run. Any run you make, you get the full history. Whereas for Express, you have to look into CloudWatch. Then the pricing is also different. Um, the standard workflow is quite cheaper compared. The Express workflow is quite cheaper compared to the standard. Okay, and this is because of the duration and also the number of times you can invoke. Then this is best for business processes like order and something that will need approval. Okay, whereas um, this will be better for high volume events that require 10K per second, um, 10K per second transaction. So if you have an event that needs to be carried out in high volume, okay, and is going to run short term, then Express workflow will be best for you to use. And we are going to look at that tonight. Okay, so we are going to head into the coding session now, where we are going to deploy our Lambda function, and we are also going to deploy our step function to orchestrate this lambda, these lambdas that we are trying to set up. All right. So I'm going to go to my AWS Management Console now. Let me share my screen. Just give me a moment. So my screen should be showing by now, I guess. Okay. So I guess we are all good. So we are on the AWS Management Console now. And first, we are going to set up our Lambda function. So first, let's look at what we are actually going to be deploying, right? So let's look at what we are going to be deploying first before we go into that. So let's look. So we are going to be deploying a simple transactional workflow step function to run a simple transactional workflow. So I've set up a step machine here already. So I'm just going to show you the visual. So I named it test, tested it some couple of times. Just a moment, please. Okay, so what we are going to be deploying will look similar to this. Let me take this off and take this. Yeah. So our workflow is going to look like this. So this is a payment or a transactional workflow. So a user makes a request for a particular item, and we want to see if the request if the request gets successful, what will happen, and if it fails, what will happen. So this is what is happening here. So the first, we have three Lambda functions. We're going to be setting up three Lambda functions, and they're all going to be running different processes. Okay, the first Lambda function is going to be running the process. Okay, so it's more like the validation process. So it's going to validate if your your item is available or not. Okay, if it's available, then it's going to also check if your card is billable or not. Okay, so more like if your card is yes, if your card is billable or not. So basically, so that's what it's doing. So it checks for that process. If it is successful, it comes to process result. Okay, where you're going to get the success. You're going to get the success result here. And if it fails, then it goes to the the purchase field function. So the process field function is also going to do some checks as well. So it will check for the particular error that is being that is being dropped. Okay, so it catches the error. So based on some parameters that have we are going to be setting in the purchase error. So the error will be filtered out, and let's assume the error um, let's assume the error is due to, let's assume the card was debited, okay, but an error occurred after the card was debited. Okay, so that error will be flagged, and refund will be triggered. So refund will now continue with the process, okay, from this point and refund back the money to the user. Okay, so that's what this flow is all about. So it's just a basic flow to actually demonstrate the power of step function. All right, so let's head to. So first, we are going to set up our lambda functions. So let's quickly do that. So we're going to head on to lambda. So I'll click on lambda. All right, so I'll click on create function. So let's create our first function. Let's create our first function. So let's name our first function from our workflow. Let's see from our workflow what's the name of our function again. So the name of our function is process purchase. Okay, so let's create a lambda function and let's name it process purchase. So I'm going to call it process purchase, or let me just say purchase function instead. Something easy, easily relatable. So it's always good to actually name your resources. So I'm just going to call it um, purchase. So let's say purchase handler, purchase handler, product purchase handler. Okay, then I'm going to change the runtime to Python. So I'll leave it at 3.12 and I'll head on to create function. So let's wait for it to create. Okay, all this wizard are not needed. Okay, let's dismiss this. We don't need that. Okay, so if you scroll down, let's scroll down to the visual editor and let's paste in our Python code. Okay, so we are going to take this out and paste in our Python code. So all of this will be made available for you guys to practice along. Why is it not pasting? Just hold on. Okay, let me paste and see. Okay, so we have our Python code here. So what is this doing? So first of all, is importing the libraries random and strange, and we set a function here. Okay, so we wrote out some couple of things here for the payment. So this is the this is what the handler is going to be doing, the lambda handler. So first is going to get the events. Okay, so the order, that's actually the order that I'm going to be passing in as a JSON. So the order we passed in as JSON from the input, that's I'm going to pass in an input, a JSON payload. So it's going to trigger the function, it's going to run through it. Okay, so it's going to get that, and it's going to be looking at order and payment. And so if the card so we have a statement here, our conditional statement here. So if the card gets declined, then this is what should be this is the exception. Okay, so you raise an exception here. So if card is if payment declined error and card is ending with 000, meaning the card is declined, right? So you are going to have a message, okay, for that. Okay, it's going to um, trigger the next function that is going to be handling errors for for card with exceptional errors. Okay, card with that is having that drops. So it will trigger the 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 next lambda function that we are going to be setting up. Okay, after this. Okay, whereas if it is successful, it's going to return a purchase past success. So this will be your result if things goes well. Okay, so we are going to click on deploy. So that has been deployed successfully. So let's create another lambda function for. I'm going to take this out. Okay. Okay, so this is what we just created, product purchase handler. Okay, so let's create another function. So the next function will be for the purchase field handler. So if our purchase fails, if the card fails, if it gets declined, what will happen? So this is the lambda that is going to be handling that function for us. So the name of our lambda will be product refund, product refund handler. Okay, product refund handler. That looks fine. So we scroll down to the runtime and we change this to Python. Okay, click on create function. All right, so we are here now. Let's paste in our code for the what we have for the purchase. All right, so for the refund handler, we're almost doing the same thing, but at this point we get an exception. Okay, if we write if we get an exception, then the refund error. Okay, so no, we get this message: no transactional ID found in the event. So if if the user tries to make a request, and from what the payload we are going to be imputing, if it doesn't match, then um, this function will get triggered. Okay, and if it's successful, if that's if the purchase fails, then it will trigger this lambda function. Okay, and once it triggers this lambda function is changed to the refund function, which is going to refund back the money to the user. That is when the user's account have been subcharged. Okay, so the user account was subcharged, but at um, the validation process, it discovers an error. Let's say um, there is a um, there is a transaction that there is a, let's say, a downtime with one of the services. So the that's I'm just painting an analogy, right? So there is a, let's say, a crackdown somewhere. So we have to refund the money back to the user. So this is what this function is going to be doing. So it's going to be triggering the next function for refund. So the next handler we're going to be creating will be the final handler, which will be our result handler. So this is our result handler. So the result handler is going to be the end of the process. So if the process was successful, if it wasn't successful, we get that at the result. Okay. So I'm going to paste this now. All right. So this is the result. This is the Python code that is going to be running on the function for results. Okay, so if purchase gets successful, what are we going to get? The messages we are going to get. If not, do refund. Okay, so this is like the last point. So let's see, let's see this in more detail. Let me take this out. Okay, so wait, I think I didn't take this. Okay, so this is more cleaner. Okay, so if you purchase and the result is successful, then you get the message. Okay, your transaction with your transaction ID. Okay, your payment was successful. But if it's not successful, then you can see the else if statement here that is going to be outputting is going to be outputting the results that is being gotten from the refund function. Okay, so it gets the output as an input from the result function. Then you get you have successfully received your refund. Okay, or else if this doesn't fall into these categories, you get this message not recognized as an event. Okay, so this is basically what this result function is doing. So I'm going to deploy this now. Okay, so we have our resources, our Lambda resources created now, all created. So we have our three Lambda functions. So the product purchase handler, which is going to be getting the input from the user. Okay, so I'm going to be passing a JSON payload that is going to be containing transactional information. Okay, so I'll pass in uh, those information here, and it checks if successful or not. Okay, if it is not successful, let's say it has an exceptional error, an error that we are going to be filtering using this product refund. So the output will be fed into product refund handler. So the product refund handler will now um, process the refunding fees. Okay, and you get that as an input from result handler, which is going to tell the user you've received your refund. Okay, so that's basically what's happening here. And if it is successful, then you just go straight to result handler. So let's set this up, okay, on step function. So I'll go to step function, and let's create a state machine. So I'll click on create state machine, and we have create from blank and create from template. So if you want to create from scratch, you can use this. But if you want some pre-built templates to to get started with, you can go with some create with template. But for this, you're going to be using create from blank option. Then the state machine name, I'm going to call it payment, or I'll call it uh, processing, order processing workflow. Okay. Then from the state machine type, we have the standard and we have the express. Okay. Previously, we discussed what the standard is and what the express means. So we see the standard can run for 1 year, whereas the express can only run for 5 minutes. Okay. And this is used for running workload that are majorly transactional, right? So with workload that will be needing retries and will run for a long period of time. So we use standard for that. Okay. Whereas Express is used for running, let's say, high volume of workload at a go and under a short period of time. So Express is good for that. And we say standard is also more expensive compared to Express. So we are going to go with standard. So since this is a transactional application we are trying to build, I'll click on this. So we have a UI here. This is the GUI for step function. So step function offers you a GUI, a very intuitive GUI for you to easily drag and drop what you want. Okay, so the resources you want to connect together, the workflow you want to build, you can visually design them here, and you you can yes, so you can see the actions here. From the actions, you can see the services that are available on step function. You can see the services available on step function, and this is basically all the whole services on AWS actually. So you can even attach models, AI models as well. So uh, you can run functions on AI model. Let's say a user tries to make a request, it triggers Bedrock, and Bedrock gives a reply. So you can set up some interesting workload like that using step function. All right. So We also have the flow. So the flow talks about the different services or the different yes, the different tasks we can run. We can run on step function. So we have the choice. We spoke about the choice. We say this the choice helps for if else logic. So if you want to run a conditional statement, okay, if a certain condition is being met, then do this. If not, do this. So that's what this choice is all about. Then we have the parallel. Parallel is used for running multiple branches of workload or of yes of resources. Okay, you want to run multiple resources at a go, you use parallel to do that. Then we have the map. So the map is more like you want to iterate through a list of items. So you want them to run um, in sequence. Okay, you want them to run in sequence. Then you use the map. Then we have the pass. Pass is used for placeholder. We have the wait. Wait is used for delay. So if you want to wait or you want to pause for some certain action to be completed, then you use this wait. Then we have the success. To for success, that's if your if if the workflow hits success, this is what should happen. Then failure, if it should hit failure. So this is the flow, right? Then we have the pattern. So the pattern is out of the box. Step function also offers you out of the box templates that you can easily use for setting up some things on AWS. So we have process antenna manifest, process S3 object. So these are basically templates, right? Um, these are basically functions, more like functions you can easily integrate and make your workload much more easier. So we have the design mode and we have the code mode. So if you want to code using Amazon resource language, or you want to use JSON for 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 writing your code, so for writing your configuration, sorry, then you come here and you do that. Okay, and it's very easy for those of you comfortable writing code. Okay, and you can also design. The good thing about step function is that you can design visually here. Okay, so after you design, let's assume I drag my lambda here now. You can see under the code, you see that I have a bunch of code that have been written lambda, so I can visually drag and drop and still get my code. Okay, and after I've gotten this code, I can now then integrate that into my infrastructure as a code. That's my Terraform or my Pulumi. They also have config if you want to use config. Uh, then okay, let's deep let's dive into this now. So let's create our first workflow. So the first workflow, the first thing we're going to be creating is the purchase the the product purchase yes, the product purchase function, right? So we've created a product purchase here. So we can name it. So product purchase. Just hold on. What is happening? Okay. So let's name this products or process purchase. So I'm going to name it process purchase. I'm going to name it process purchase. Then I'll come here. So here you find integration type. So we have optimized and we have SDK. So if you want to integrate using SDKs, you can have that there. Then we also have API arguments. So function name, you can find function name is actually that's the API. If you want to connect the API, okay, that's your Lambda function or any API that you have. So this is where you do the connection. So I'm going to select the product purchase handler. So this is the product purchase, which will be the product purchase handler that was created previously on Lambda. So I'm going to select that from API argument here. Then we have the payload. So I will leave it at use state input as payload. Okay. But if you have any other option, you can use that. Then if you want to add a weight, just like we discussed, you can add a weight, a weight here. Okay, so you can see I get this. So if you want to, you have to set up this logic in your code where you're going to receive a token, and with that token, you'll be able to like accept or deny your weight. Then what? Then we just leave everything as this, and once you click out, it gets created automatically. So we have set up our first workflow. So the next thing on our workflow, we still grab we still it's still another function. So we'll grab our invoke lambda function, and we place it beneath process purchase. So this will be our refund. Yes, it's going to be our refund. Uh, so this is going to be the refund and handler. So I'm going to be naming it the product and refund or purchase refund or refund. Let me say refund purchase. So I'll name it refund purchase. Then integration type, leave everything as default. Function name, I'm going to select the refund purchase. So I'm going to select the product refund purchase or refund handler. The product refund handler, I'm going to select that. Then I'll leave everything as default. Then I'll go back to the process purchase. Okay, so the process purchase, under the process purchase, I want to be able to like pick up some errors. Okay, so if you look at the code properly, we said if the input we are passing, if the card get declines and it has some certain error code, we want to pick out that error code and pass that input into the refund purchase. Okay, so the kind of error we are going to be looking at, we can define those errors under this tab. Okay, so we have the retry on error. So we have the retry on error. So I'll leave that for now. Okay, so what we are interested in is the catch error. So we want to catch a particular error, and we are going to be catching the error. If you look at our Lambda code for, let me go to function product purchase. to load what we are actually tracking. Okay, so what we are tracking from the card, if you see here, if card gets an exception here, so if we get an exception here for payment declined, so payment declined error. Okay, if we get this exception, we are going to trigger the second lambda function for refund. So I'm going to copy that and I'm going to put that under this payment declined error, and the type of error I'm going to paste it here, and I'll hit enter so it gets selected. Okay, all right, so let's run this up very fast. So I'm going to leave that as it is. And yes, then I'll come to fallback state. So fallback state, I'm going to select the fallback. So this is where I want the purchase to fall to. So if this error is being detected in the during the purchase process, okay, if this error is being detected, that's payment declined, or payment, yes, payment decline error. If we get payment decline error during the process, then it triggers a refund purchase. So we click on this and you see that from the visual representation here, you see that the arrow now branches. Okay, the arrow with the catch error now branches to refund purchase. Okay, so if you see something like this, it means you are on track of what you are doing. So the next thing now is you're going to set up now is the result, right? So I'm going to still create an invoke, lambda invoke. Please note it's lambda invoke. Okay, there are a lot of lambda actions here, but what we are using is the lambda invoke because we're invoking lambda. So so the next is going to be the results. So I'm going to drag it and place beneath my refund purchase, and it looks like this. But if you look closely, the flow doesn't look right. So let's correct that. So I'm going to come to lambda invoke here, and I'm going to rename this into my results purchase. So I'm going to say my results. Yeah, I'm just going to say my, okay, I'm just going to say my results from the purchase. Okay, then I'll scroll down to function type, and I'm going to select the function for results, the lambda function we created. I'm just going to select it from this drop down. So you click on it, you're going to see it, results handler. So I'm going to click on the results handler. Then I'm going to leave everything as it is. Okay. Then purchase results. Okay, sorry for that. So we need to, if you look here, the results, the purchase process is not pointing directly to the result process, which would be a problem because if payment is successful, it doesn't it doesn't need to go through refund purchase. It needs to go directly to the result purchase. Okay, so we need to find a way to map this to this instead of this. So I'll go to process purchase, and under configuration, the end. Okay, next state, I'm going to change it from refund purchase to the result purchase. Okay, so it will now look like this. So we now have the refund purchase here and we have the result purchase here. So if payment is successful, then the transaction get directed to the result purchase. Whereas if it fails and from the failure we have an exception error that we have defined under refund to be payment declined, okay, card declined. So if there is an exception error like that, then it will go through this route, okay, which is the refund process. So the user will get refunded and we get the message here for results purchase, and that's the end. So this is basically what a typical workflow will look like. Okay, although this is very simple, your own workflow might be more complex than this, but this gives you like a head start on what and what to do, how to navigate the whole console. That's the essence. Okay, so I'm going to click on create, and you can see another good thing is that I don't need to go and create IAM rows separately. Automatically, Step Function does that for me. So the necessary IAM rows that I need will all be created. So I'll just click on confirm. Okay, let's wait for that. Okay, all right. So state machine have been successfully deployed. Now let's test. So to test this out, I'm going to paste in my JSON payloads, which I'm going to do here. So I'm going to come here, I'll come to state machines and just test it out directly. So I'm going to click on where is my state machine? Yeah. So this is my state machine order processing workflow. I'm going to click on it. Then I'm going to start an execution. So I'm going to paste in my JSON payload here. So I'm going to copy that out now and paste it there to in action. So I'm going to paste this, copy and paste. Just paste it from my documentation here. So this is the success. This is a success payload. So everything is successful. We should get a message. So I'm going to paste in. I'm going to paste this here. So if you look here, you can see the order. So I made some order here. This is the order ID. This is the customer ID, and this is the payment. Okay, so cardless, um, and card last four. These are the IDs. Okay, and these are the quantities. So I've already set some parameters in my Lambda. So if it doesn't work with that parameter, then it drops the payment. So just click on start. And it gets started. You can see visually. Another good thing is the visual view of how workflow is being executed. So you can see after I tested my payload, my JSON payload. So I'm assuming a user, in a real case, it will be a user at the front end imputing what they want. Okay, imputing, selecting their product, and once they hit enter, it triggers an API, and the API communicates with the Lambda function. So that's what will be happening in real life. Okay, but just for this demo, we are just using JSON payload directly imputing our APIs. So it it hits the first Lambda function and it checks if the parameters are correct, if matches with what we have. And if it's true, then it goes to result. Okay, so it is the result, and we get the result output. Okay, and this is the output. So we get the order, and you can see um, the transaction was successful. Okay, so you can see it was a success. Okay, purchase process success. Okay, and you can see everything here. Okay, so that is for success. So let's see for failure. Let's simulate for failure. Let's see if the card has an issue. Let's see what will happen. Okay, so I'm going to do another test. I'm going to start another execution here, and I'm going to paste this transaction. So this is the second transaction, okay? And then you can see the quantity, and you can see the payment, and you can see it was specified 00000. And if you can remember from our Lambda function, we set um, an exception for that. So I'm going to click on start execution, and immediately it failed. And let's see what happened. And yes, you can see it failed. Okay, so the process failed. Okay, so this is, yeah, so you can see the process failed because of the ID was not correct. Okay, so this is basically a typical example of what you're going to be. This is a typical example of how a workflow, a step function can be used to like automate a workflow. Okay, so in a more bigger fashion, you will have a UI. Okay, and from that UI, users can input what they want or select what they want, and at the back end, it hits a Lambda function that runs the processes. If there is an exception to what you've defined, then those exceptions will be flagged if those processes hit the Lambda. Okay, hit Lambda. So if it is successful, it goes to success. If it is a failure, it goes to failure. If it is an exception, then it goes to exception. What is going to happen if else this? Okay, so it goes to the exception. So the exception is get a refund, or let's say retry. Okay, retry after 5 minutes or after 30 minutes. Um, retry 5 times for 30 minutes. Sorry, 30 minutes is quite long for 30 seconds. Okay, so that will be like the logic. So I hope this is clear. I've tried to, because of time, we can I've elapsed my time, and we can't go too deep for today. So I hope this is clear. Mr. Moderator, you can take it from here. I don't know. I can't hear you for some reason.
Clearly. Okay.
Yes.
Yeah. Yeah. So thank you, Prosper, for the time on the call, sharing this knowledge. So much you've shared, and I don't want to keep our audience waiting. We'll just go straight to our couch session. If you need to go back to the video, it's all on our YouTube page, and so that you could, you know, practice, go along with it, and you'll be glad if you can share the GitHub repo, uh, you know, with the community, so that they participate along, with what you've shared. So I just want to go along with the couch session today, so that we wrap up uh, today. I want to. Can you see my screen?
Okay.
Can you see my screen? Can anyone see my screen? If you can see my screen, let me. I'd like to see thumbs up from you guys. If you can see my screen, so that I can start the. Can you see my screen? Okay. Okay. So I'm going to start the cow session now. Okay. I'll try to start the cow session. So you can join and using this thing, 5 questions based on what Prosper has shared. And so let me know if you are joining their prizes to be won by the winner of this cow session. Let me know. Any participant, are there no participants on this cow session? Okay, we have D. Uh, 1 more minute to go, and I will actually, hit start the session. Anyone who wants to join, you just have 1 more minute, and I'll hit the start button. Okay, I'll be starting the cow session now. Oh, okay. We didn't have any. Oh, okay. I'll go to the next question. Oh, we have some. Okay, okay. To the next question. D is leading. To the third question now. Okay, let's see. Okay, D is still leading. Let's go to the next question. Okay. And who is leading? Who is the scoreboard leader? Let's see. Okay. Then let's see whether we're gonna have a change of, you know, in the at the scoreboard tonight. The last question. So let's see who is the winner for this cow session. Oh, and the winner is D, who had 731. Oh,
That was very close.
so the winner should, you know, an email will be displayed on at the screen. Please do well to send us an email for stating you are the winner of the cow session for the week 10 AWS study series. It was a close one.
Yeah,
EMC
it was a
was
close one.
very was pushing, and I thought there was going to be a change in the leaderboard, but then the winners, Hannah moment crossing. So send us uh
Congratulations.
use through this email displayed on the screen at the bottom of the screen, and then your gift will be sent to you, and you can apply that in learning and practicing what our Prosper shared with us on function AWS. And if you need, the community is open, and the community is growing. Be part of the community, and also know that in few months' time we'll be also having our community day this year, October 17th. And do well to follow us on our social media. Follow the event that is happening. And so, thank you for everyone that has joined, that has been part of today's event. We really appreciate your time. We really appreciate the moment that you have spent with us. And so, Prosper, please do not forget to share the
Yes,
repo. Can you drop the link?
yes, I'll drop the
Can
link.
you drop the link now so that people, before we end the streaming?
Okay, let me do that now.
Yeah, yeah. EMC was saying network wasn't too friendly. Yes, it happens. Unstable network could affect. So yeah, but thank you for hanging, for pushing it to the final moment. It was a great one. We're bringing the competition, to one of great contest. Are you dropping the link, Prosper?
Yes, yes, I'm dropping the link.
Okay,
Just hold on.
okay.
Let's see. Let me sign in.
Thank you. Silvic Hamasa for the word.
Any question? So I saw a question from
Okay, yeah. So let me display the question. It say the question reads: could we write the function in other runtime programming languages, not only Python? Because currently I work with Java.
yes, yes, yes. We you can actually write in any preferred programming languages like Lambda from the Lambda execution. There you can see we have different um, Java runtimes on Lambda. So you can write with Node.js, write with Java, any kind of runtime at all. AWS have a very large community supporting different programming languages. So your workload, you can run any workload with any programming languages of your choice. Not only it's not restricted to only Python.
Okay,
But for
okay,
step function is not tied to a programming language per se. Step function is more like a scripting. It uses on the Amazon resource language, of like JSON, okay, for scripting the definition of what you actually want. So that's please take note of that.
okay. That's well noted. Thank you so much for the repo. We're still waiting. Have you dropped it?
I'm
We're waiting for the
trying to
repo.
log in.
Okay.
Any other question?
That's the only question on the chat, and that's been answered.
Okay, so I'm dropping the link now.
Just drop it.
So I'm dropping it on the private chat.
Okay. So we're just waiting for the link to be shared, and okay. So we have so that's the link to the repo for practice. Thank you, Prosper, for as we bring this live stream to an end. We'll also drop this repo uh, on the group, for anyone who wants to practice, so that they can also learn along when they watch the video. Thank you so much for everyone who has joined. We appreciate and stay tuned to the AWS West African Cloud Security User Group uh, channel as we bring you next week for another amazing learning studies series. Thank you so much and have a wonderful weekend.
Thank you very much. Thank you very much, everyone.